So this recording is probably going to be about an hour and a half long. This is going to be a beast of a file to upload in a little bit. But we're going to be talking about basically rendering our stuff and trying to get this into post-processing. And I'll probably show you guys Nuke just a little bit, just so you kind of understand why we're making these decisions. Like, why do you want to separate lighting? Why do you want to use render passes? I know most of you haven't taken a compositing class yet, so you don't really understand the technique of what you're eventually going to do with this stuff. But this is going to be a really good way just to kind of get you guys used to the workflow of getting into an application like Nuke. Because a lot of you guys are going to love Nuke. I don't know if you've tinkered with it very much, but Nuke's an amazing software package if you haven't used it yet. So a couple things to kind of cover real quick. Someone earlier had mentioned some noise in the render. How many of you guys were getting little speckly white dots around the bottle or the metal pieces, that whole area to the right of the pulley? Okay, were you probably seeing that it was either white or like a yellow or an orange, something like that, maybe red? Yeah. It is. So what's happening with that thing? I mean, I'm not really going to be taking off points for that because I'm used to seeing it. So some of you guys will be seeing noise, and I'll kind of show you how to fix it. It's an issue with the warm light's visibility. Let's try that. I think this might have it. Okay. Yeah, so here's the issue. And some of you may not even have seen any problems. If you didn't have that issue, don't worry about fixing this thing. But if you want to try to clean up the grain before you do your final batch renders, you know how we were doing these physical area lights, and it kind of came with like the Mila light connected to it. There was that little black body. So by doing this automatically turned on a bunch of stuff over here in the area light attributes. And if you kind of look in the mental ray section, like the light shape was turned on, you guys turned it to a sphere. That's perfectly fine. But this thing right here, do you remember what the visible checkbox was doing? Yeah, so if this is off, you know how all those lights generate that fake specularity, that little highlight? It's not a real thing. It's like Maya's trick to make it look like you're reflecting a light source. But with this on by default, which all of you probably have it on by default right now, there are parts of the scene that are hitting this with reflection rays, almost like a giant white ball is like just sitting there in space, which is fine. But what happens is, like, let's say you have something like metal right here, and it shoots out a bunch of reflection rays. Most of the rays are probably going to hit the book, the wall, other stuff that are typically between 0 and 1, black and white. But this guy right here, you can see where the intensity is way higher. So if you have, let's say you send out 10 rays, 9 of the rays all hit some 0.5, 0.6 number, something fairly middle of the road, and you have one random ray that hits that light and generates a reflection value of 100. What do you think that's going to do to the average of all those samples when you have this one number that's like way, way higher than the rest? Yeah, now your average is thrown off, and so that's when you see samples spike into this, like, these little white dots everywhere. And sometimes, like, a few different channels will do it. So if you see yellow dots, that means the red and the green channels are both spiking. White is all 3 are spiking. But essentially, like, the way for you to fix this, if you feel like you have that problem, just go to that light, just uncheck visibility. So let that light go back to specularity and not try to do that, like, bright shape sitting in space. That makes sense? Yeah, and again, like, even if it was in the submission, I'm not going to take off points for that. I forgot to talk to you guys about it, but it's just simply a reflection issue with that particular light. So turn visible off. Okay. Now we can do all the fun stuff with render layers. So I'm going to be using the lecture project, and if you guys have your lab scene like pretty much ready to go, feel free to do that. But I'm going to kind of pick up where we left off when we finished the bottle in the last one. Hopefully. I think I saved this. Yep. So looks like my bottle's pretty much built. That seems okay. Yeah, label, glass. Okay, yeah, so everything was saved from the last time. Now, what we want to do is start breaking these final renders apart, because the whole scene's done, right? We just want to get this into something else like Nuke so we can start doing some fun stuff to it. So I'm just going to kind of go through the PDF document and just kind of show you the different steps you're going to have to do. And eventually, because with the way the class is set up now with all these new Mila things, it kind of pushed out another lecture that I wanted to teach where I was going to have you guys in Nuke, like doing depth of field and vignettes and all this really cool stuff. But since we don't have enough lectures to do that, I'm still going to record the videos. So if you guys are subscribed to my YouTube channel, you'll probably see a playlist of all this Nuke stuff pop up within the next couple weeks. Feel free to watch it, and hold on to your files, because some of you guys could actually take your project that you finished this month and just hop right in Nuke and start doing a lot of the same stuff I'm doing. But it's really cool, and I think you guys are going to want to try doing some of this stuff. But for right now, it's just how do we do all the rendering? Like, how do we get this stuff out of Maya? Now, have you guys done much batch rendering up to this point? Do you know like what a couple of you have? Do you know what a batch render is though? It's like a sequence, basically, and you've noticed that it launches like a separate application of Maya, and it's kind of bouncing off to the side and rendering, but you can still be in Maya and do other stuff kind of while it's going on. Now, what we want to do with the batch render is, instead of you guys just rendering something in here and getting like a 2D image, which is fine if you're just posting it somewhere to show somebody, but if you're still trying to control it and make like highlights brighter, you might want to change the color of a texture or do a defocus on an object. There's a lot of different things you may want to do in post, to kind of tweak this thing. We need to break it up into different pieces. So there's a bunch of different ways to break the scene apart. You can separate things by object, and you guys have probably seen that done before, where it's like foreground elements layering over a background element. It's called a merge over. You see it a lot with like movie breakdowns where they just start layering CG things like over top of like some type of backplate. Those are overs, and that's just simply rendering pieces one by one, and then you just merge them together inside of Nuke or Photoshop or After Effects. We're not going to be doing that one a whole lot, but what I do want to do is do light separation. Like, it'd be nice to have the lights as different renders. That way you could like shut a light off, change the color of one of your lights if you needed to. I might want to control the material properties separately, like making spec highlights brighter, changing the indirect light on an object, so maybe the bounce light is a little brighter hitting something. Now, the first way we're going to do this is just by breaking apart the lighting. So in this guy, you'll kind of see at the top, it's right here for step 3. It wants us to do 3 different light render layers, and we'll kind of come back to this one here when we're done, but I need to do 3 different light render layers to separate the 3 different lights in the scene. You've got the key light, the warm light, and the IBL. Those are your 3 light sources. Now, if you are missing one of these from like week 1, maybe just make another light real quick just so you have something to render. But do all of you have like all 3 of those in your scene? Yeah, you probably, okay, if you do, you're good to go. Now, have you guys done render layers before? No, okay. But do you remember how these little display layers work? Probably a lot of you guys have been using these like to kind of hide and show different things, sort of like visibility tricks. So the render layers are right next to it. Now, if you guys are in, is anyone in 2016 extension 2? Are you in it right now? You're probably noticing yours does not look like that, right? Okay. If anyone's using extension 2, don't. Like, just go back to like one of the service packs before extension 2, because extension 2 in 2017, they've like reworked this whole thing, right, when I decided to do my videos.
What is it not supposed to look like?
It's, the render layers don't have the same setup over here. They have like all new panels and like, it looks like the relationship editor. Does yours look like that still?
It looks very similar to that.
Okay. You might be fine, but like in my extension 2, it's like completely different. So if you guys are using extension 2, just go back to the other one.
I'm still in Service Pack 4.
Oh, you're good to go. Yeah, Service Pack 4 is perfect. Extension 2 is like something, does anyone even have that? A couple of you? Yeah. It's like a different version of Maya. It's like 2016.5, basically. It's like their beta for 2017. But yeah, just stick with 2016 Service Pack 4 through 6. One of those is fine. Okay, so the render layers are over here on the right, And they kind of work the same way as display layers. You can assign objects. But the thing that's a little different with this is instead of it just being like groups that you kind of hide and show, think of this like different versions of your scene. So for example, what we want to do in order to split the lights up is I first need to make a render layer with just the geometry. At least get those guys in their own layer. So just go in your scene, select all of your geometry. So in the lab, you know, the shelf, the books, the wall, pulley, grab all the geo. And I'm doing it through the outliner, but you could probably also just drag right here in the viewport. But yeah, select all the geometry. And then on the right, see that button on the right-hand side with the little sphere? Create new layer and assign selected objects. Just like display layers. Hit that button. Watch what happens. So notice how it's made a new layer. It's called layer 1. Now look at the viewport when I click on it. Yeah, question? Yep, it's create new layer and assign selected objects. Yep. And now when you do that, like look at the viewport when I click between the two. See how you can only be on one layer at a time? And when I do that, what happens to the scene? Like what are we seeing at this point? Yeah, I lose all the lighting. I only see what I assigned to it. Now this means if I rendered this, what would it probably look like? Black, right? There's no lights. There's no lights. It should be a black render, right? Now what we're talking about doing is splitting apart the light sources. So we want to do one for just the key light. So what's our obvious first step? Yeah, get the key light on that layer. So in this case right here for the lecture, I didn't really name these key and fill light or warm light, but this one right here, the small one, that's the key light technically. I mean, in the lab, it's that giant area light off to the left that you guys have already set up. But just click on the key light. You might need to go back to the master layer to see it. Or if you have the outliner open, you can just select it that way. But somehow click on the key light. And then what I want you to do is right click on layer 1. And then you're going to pick add selected objects, which is just going to add that to the layer. So see how that appeared? There it is. Now the key light is on that layer. And since this one is going to be for the key light, we're going to rename this too. Instead of it being layer 1, I'm going to call it key light layer. Now, what we need to do now is just make sure it looks right. Like that would kind of make sense because I mean, I think I have it set up right. It's only one light source. Seems okay. You don't have to do this with me, but I'm just going to hop in the render settings and I'm going to turn on the GI prototype because eventually we would use this for the final renders. I'm just going to keep my settings really low. I kind of want to see like what is this going to look like if I did batch render it. So I'm going to be on the key light layer. GI's turned on. Samples are all really low though. And I'm just going to hop into the render view and then try rendering on the key light layer just to see visually what it looks like. And when you're in the lab, like Seth can kind of tell you just by looking at the render if it's correct, because we've kind of seen this quite a bit at this point. But I can see like, okay, there's illumination coming from what looks like the key light. Like that's a good sign. Ton of grain, but that's kind of expected, you know, since we have the settings so low. I'm not going to even wait for the bottle. I mean, unless you guys want to be here for an hour again. But let's not do that. Like, I'm just going to look at the rest of the shot, and we can probably tell just by looking at that left half if things are good. I'm not that worried about the bottle. The bottle, if everything else works, the bottle's going to be fine. Now, even at this point, does it seem like it's correct, you guys? Yeah, like it looks like the key light is definitely there. Now, the other light, like the warm light, if that was here, we'd probably be seeing some like warm illumination right there. And because it's coming from behind the objects, that means that the warm light would have made a bunch of shadows down here. I'm not seeing that. I only see one set of shadows, so that's probably one light source. And over here in the bottle, like we should see a highlight and probably nothing behind it. Like there should not be any like warm specularity. I think it's actually rendering kind of okay right now. How bad was the vial for the renders in that lab? The laughing is not reassuring. It was like, was it pretty brutal? Like just waiting? Half a like an hour just to like render a preview,
Oh, no.
or just
Not for copy.
a half hour for the final render. That's actually pretty good. Yeah, that's a pretty good render. Yeah. Yeah. I was battling that with mine, like, because I was like doing a bunch of batch render tests with this guy last night, and I just like kicked it off, and I was like playing some video games, and I came back to my laptop, and it was like 5 hours in. The bottle was stuck right up here, and you guys may have noticed that even on the lip of the vial, it was just hanging out forever, or maybe like right where it sits on the shelf, like all that curved detail, like that's just devastating on the render. It's just kind of the way it is, unfortunately. But these high render times, I know 30 minutes or an hour might seem like terrible. Have you guys actually like ever looked up production render times for like movies? Yeah. So one of the best examples of this is you guys have all probably seen Chronicles of Narnia at some point, or at least like previews of it. You remember the lion? All the hair. So one of the things they did is they wanted to make the hair look realistic, and they added in this thing called occlusion. And I'm going to have you guys do occlusion today as well. But occlusion, I might get the teeth thing again. Oh, not teeth. Well, you can actually see the other images of occlusion. Like, does this kind of visually look familiar? Like that type of image, where it looks like kind of soft gray contact shadows everywhere. So this is used in game engines a lot. Maya kind of has a really cheap viewport occlusion. I don't know if you've ever seen that button before, right there. See how it's putting those little contact shadows under stuff? It's just like a really, like if you guys ever do play blast, you can kind of use that to make the play blast look a little better, I guess. But they use it a lot to kind of sort of add in all this fake shadow detail. But they use it on the lion, and that's a giant fur and hair system. The render times for the occlusion, just the shadow pass for the hair, was about 99 hours a frame. A frame, yeah. There's 24 frames in a second. Then think of how many seconds that line is on screen. Yeah.
No wonder.
Yes. Like, get rid of it. So these can be pretty brutal. And the 99 hours a frame was probably for some hero shots where it's like right up against the camera, like super big. But still, like it's pretty brutal. And you're going to be experiencing stuff like that. Now, most of you won't be the guy doing the renders. Like this is just kicked off to a render farm. There's like a small team of people that just kind of watches things, which is, I'm sure, very thrilling. But yeah, like an hour frame for like a full like look development, shading and lighting shot like you guys are doing is pretty good. Like we have a lot of students in our final class right now, like the portfolio classes, that are dealing with like 3-hour frames, 4-hour frames. Obviously, it's pretty difficult to do sequences at that point because your laptop can't render enough. There's not enough time in the year to do that. But some of you guys will be using the render farm and just submitting your project, and Full Sail's render farm will pick it up and just take care of all that work for you. They'll talk more about that later when you get to like the portfolio classes, like at the end. But so this one looks pretty good. Now, one of the issues with this thing is you'll notice that on the right side right there, there's blue lighting. And look at the bottle. Do you guys know what that circular reflection is right there? Well, so this is the area light. Yeah, that little like, that specularity right in the middle, that's the light source. What is that weird thing? Yeah, let me back up to the master layer. See this guy? We didn't add it to the layer. However, one of the problems with render layers is the IBL is some magical force, which apparently doesn't obey layer display properties. So even if this is not on the layer, like we never added the IBL, this is still magically casting light. That's why there's blue light right here. This should have been black, because if it wasn't being hit by the area light, it should have been completely black. But you can see all this fill everywhere where everything's getting a little bit of illumination. That's the IBL. That's going to happen in your project too. So what are some different ways that I could manually turn off the IBL? Because apparently hiding it doesn't matter, because it's hidden right now and it's still doing something. So how could I turn that off manually without deleting it? Yeah, like I could go in there, and if I turn off the GI prototype or like Final Gather, that would stop it, right? Because that's how the IBL works, is with those indirect lighting solvers. But if I turn these off, that means I don't get any bounced light. And I kind of want that for the key light. So that stinks. But what we could do is if you just go to the IBL's attributes. So load up the IBL attributes and go to the render stats area. We kind of talked about this area a little bit back in probably lecture 2. You remember what these checkboxes were doing, or kind of what this stuff was down here? Because I think all of you changed that to like 50% gray. You remember like what this whole area does? And you can probably look at the attributes and sort of figure out what's going to happen if you turn it off. Yeah, it's just like you basically turning, like, do you want to see it as a background? Like the visibility of it, does that matter to you? Do you want to see it as a reflection? Like if there's a mirror, do you want to see it reflecting in a mirror? Do you want to see it in refractions? Like if you're inside an interior environment looking through a window, do you want to see it behind the window outside? So these are all ways to kind of turn that off. But this is also how we can just shut it off permanently so it doesn't do anything. Now, one of the tricks with this is I don't want to turn it off forever because we're still going to need it on that IBL layer. And I don't want you guys like turning it on and off manually because that leaves like, that's user error. That's like extra stuff you have to babysit and worry about. So what we're going to do that's a little different is instead of me just unchecking these, try right clicking where it says primary visibility. How many of you guys only see lock attribute? Okay. So just in case when you get to the lab, or if you try doing this, if you only see lock attribute, it means you are on the master layer. That's it. So the master layer doesn't have this other option called create render layer override. So if you right click on it when you're on the key light layer or any of the new render layers, and I'll right click on the same thing. See how there's that extra attribute that keeps popping up? This is something unique to the render layers. So hit it, like do create layer override. See how it turns it orange? Right click and do the override on all 5 of those visible checkboxes. Right there. So make them all orange. Once you've turned them orange and they have that override, just go right down and unclick them. So it's turned off. But because we made it an override first before we shut it off, look what happens if I go back to the master layer and look at the same thing. They're still on. Yep.
Which layer do we need to be on to uncheck everything?
So you're going to be on the key light layer. Yep. And obviously you do this for the warm light layer eventually. We'd have to turn it back on for the IBL layer when we do want it to be enabled. So this is something you're going to be dealing with on the key, warm, and IBL layers. Just going in there, making the override, shutting it off.
And then when we want it back on, we just go in and
Yep, you just can simply like turn it back on for like the IBL layer. Yep. So these are really powerful because this lets you essentially set up different versions of your scene where you can have certain things turned off, you can change attributes. And I know you probably don't understand like the full power of this yet because you haven't had compositing, but these render layer overrides are amazing for anyone that does get into a lot of compositing because you can get really, really creative with how you use these. Like for example, like one thing I do sometimes is I'll actually make render layers for having different render settings. Like instead of me going in there and manually changing these numbers every single time I want to go to a preview render, a mid-quality render, a final render, you can do overrides on your sample sliders. So I can make a layer called test render, change all my settings to like really crappy low samples, and then make another layer called final quality. And all I'm doing is clicking between the two and never messing with any of this ever again. So like that alone is a really cool way to use this thing. But we're just pretty much doing it for the lighting. So I'm just going to keep this one, and I'm not going to render the whole thing, but let's just render that little pocket. We'll just see if that kind of fill light goes away. It should be darker there on the right side. Yeah, see how like all that blue's already gone? Like it's still grainy because my settings are low, but all that fill, that was the IBL. And if I rendered the bottle, we'd notice the reflection is gone. I'm not going to do that, but now we're down to just the key light. That's what it should look like. You'll probably notice a lot of black in your scene when you do that because one light source, there's going to be pockets where nothing is hitting it, like in a shadow. The shadow should be black, like that right there. Okay. Do you guys have any questions just about that whole process, like making the render layer, doing the overrides? Okay, that's pretty easy. Now, we're going to do the same thing for the warm light, but let's just make this easier for us and not like start from scratch again. All you got to do is just right click on the key light layer and pick duplicate layer. When you do that, see how I now have a copy of it? Like it's called key light layer 1, but it has all the same settings, same objects and lights are on it. That also means the IBL's overrides are turned off because I copied it. I'm going to rename this one warm light layer, just like you would do in the lab. So there's my warm light layer. So what's the only thing I have to change between these two? Yeah, just remove the key light, and I want to add the other one, right? The warm light. So all you do is when you're on the warm light layer, just click on your key light, right click on the layer, and you pick remove selected objects. So again, it's just like display layers. It's super easy. Then you find the warm light, just select that, and then right click and add the selected object to the layer. So I mean, the only thing you'll notice when you do it is it's just light swapping out. That's it. So I'm just going to try doing a render in the warm light layer and just see if that looks correct. I mean, it should be pretty obvious because you'll see the shadows change angle. It'll be a different color. I mean, the warm light in your project's probably pretty dark, so don't be surprised if the layer doesn't really have a whole lot of information. The key light's definitely going to be the brightest one. The warm light's pretty subtle. Yeah, I can't see much, but there is some illumination going on, so I know at least technically it's working. Yeah, you can see all that light on the side there. That's the warm light. So it's working. Two different light sources. So that one's out of the way. Now, after that, what we want to do is make the IBL layer. Now we're ready for the IBL to have its own image by itself. So we're going to right-click on the warm light layer and do duplicate layer again. I'm going to call this one IBL layer. And then for this one, we're going to need to remove this guy. So right-click, remove that light from the layer. Now, does adding this to the layer even really matter? I mean, you guys saw how before it was illuminating even though it wasn't on the layer. So you don't have to technically add the IBL. The main thing is turning off those overrides, or turning the overrides back on so I can see it. But I think what I'm going to do is add the IBL to the layer anyway. It's more of like an OCD thing. I just think visually it makes sense to sort of see that on the layer, just so you visually know, oh, that's the IBL layer. I can see it. So you can see those lights individually. There's the IBL. But the big thing here is on this layer, remember how we turned all these off earlier, and it keeps copying those settings every time we duplicate the layer. Now I want them on. This is the layer that needs the IBL. So all you're doing is just clicking on those checkboxes and it's back on. So it's on for this layer, and if you go to the other ones, you'll notice that it's still turned off. So I'll try doing a render of the IBL layer just to kind of see if that looks right. There's a lot of really cool benefits to doing this, this setup. So imagine, okay, so let's say like in the lecture room, like we have all these lights on the ceiling. Let's pretend this is a project you're doing. This is a super depressing project. These lecture rooms aren't the most exciting things, but maybe you're doing it for Full Sail. You know, they're showing it off for BTS or something. But what happens if like an art director says, I want to make this light flicker. We're trying to make it spooky. We're going to make the whole lecture room look like it's abandoned or has like, you know, some problems. How would I make that light flicker inside of Maya? SDKs. You could randomly keyframe it yourself, which is not fun, but you could do that. You could do random expressions. I don't know if you guys have dealt with those a whole lot, but you kind of know what those are, like just like a randomized curve over time. Something that looks like, let's see if I can do one here. Random time. Oh, there we go. So I'm doing this in Nuke just to kind of show you what it looks like, but that is a random expression. Don't worry if you don't know what this means. Like we're not having you actually make one, but we use these a lot in scripts to kind of add noise and chaos to something. But you could do a random expression in Maya. Like that's totally doable, or SDKs. But the problem with that is even if you did set up like a beautiful expression, you're really proud of your work. what's the only way you're going to know if the expression looks right when you render it? Yeah, you actually have to do a batch render and just wait and find out what does the image sequence looks like. You know, if the image sequence is screwed up, which it probably will be because the expression's never right the first time, like that'd be too easy. So now you're going back in Maya, changing a couple numbers on the expression, batch rendering again. Back in Maya, fix numbers, batch render again. And again, you can imagine just how long that would take waiting for sequences over and over just to see one simple adjustment. Like you guys would lose your mind doing that. But the cool thing about these render layers is if you do these individually, this allows you to potentially control the intensity inside of Nuke with random expressions. Because you saw it, like I made one right there, like just with a script. Like I just typed in this little expression, random times frame. But let me just bring in a couple of renders here real quick. I think I got it right. Where is it? Oh, I guess I could use this one as an example. So I mean, these are the ones for the lab that you guys are doing. But since these lights are going to be rendered separately, this means like potentially what you could do is if I had like a gray node under here, like multiplication is intensity, I could like put an expression on that and this would make it flicker up and down, like however I wanted. I could also go in there to the light and say, you know what? I want this light to be 10 times as bright. Actually, let's go even higher. Let's go 30 times the intensity. I can go into the color wheel and like retint it, like change the color of the light. You could make some weird like green lighting. I'll maybe do like a kind of a more of a candle light like that. And I could take the key light, because this used to be like a window, like it felt like skylight coming in. I could now take the key light and say, well, maybe on this one, I want to do a moonlight. So it's going to be a lot fainter, and I'm just going to end up exaggerating the blues, kind of push it to more of a cooler moonlight. And now if I end up combining these two different images together, I've basically like completely relit the scene in just like a minute. Right, I'm just changing lights on the fly. Like that's kind of why these are going to be great for you guys later, because just the ability to like change the intensity, make a highlight brighter, put random expressions on lights to make them flicker. Like this is really, really powerful for your portfolio later on. Cool little trick. Now, like back here, since like these render layers are pretty much good to go, so what we've got done are the different lights passes. Like the lights are broken apart, which is great. Now, one of the other things that we want to do is, since these guys are now working, I want to start setting up the render passes. Now, some of you guys have worked with this a little bit, it sounds like. Do you guys remember what render passes are supposed to do? What's up? Yeah, basically, like when you guys render something like this, you know how the meal material has all these different properties you've been stacking, like a diffuse, glossy reflection, transmission. Those can be split apart into different images, just like we're doing with the lighting. But these ones are really easy because when you do the lights, these are still physically different renders. Like it'll take a bit, but render passes don't add any render time. It just happens when you render it. It's like automatic. So the pass is in 2016, and this is the main difference if you guys look at that 2015 playlist. The render passes have changed. In 15, the passes looked like this. And some of you have probably seen this little section before. If you haven't, you're not missing much. But this is the way it used to be in many, many versions of Maya. You'd go in there, pick something. You guys probably aren't seeing this tab because you don't have it turned on in the preferences. So if you do ever want to see it and get a flashback to Maya's 2015 settings, you can go under rendering. I just have the show Maya legacy passes turned on, but you don't need to turn this on. But I'm just showing you kind of what they used to look like. The new ones, though, for 16 are under the scene tab. See how there's a little passes area? It's kind of minimized. Open that up, and you're going to see a bunch of really familiar terms. Diffuse, indirect diffuse, direct glossy, indirect glossy, refraction, scatter. I know we didn't make scatter and emission layers, but those were all different parts of the Mila material that we could create. So what you're doing is when you look at the PDF, you're just looking to create those passes right there. So these are really easy because the ones I'm having you make are all the ones that are just naturally lit up, like on the top. Not these guys on the bottom, but click on those first 4 right there. You're just turning them on. You can see how it's just basically made a pass, like they're just kind of hanging out, waiting. And then you turn on refraction. Those are the only 5 you need. So this is going to be your texture detail. Like direct diffuse is like the diffuse reflection layer, like your surface texture, like the label on the bottle. But what this does is it splits it between the direct lighting's effect with it, and then this is the bounced lights effect. So you could actually make the bounced light brighter if you wanted to on like on really anything. There's your reflections and highlights. There's the indirect reflection and highlights, like the reflection off another reflection. This one would be transmissions, refractions and transparency and transmissions. That's all the same thing. So this is your transmission layer right here. You don't need to worry about these guys. I mean, you can still make them, but they're just going to be black because we didn't do scatter or any of that stuff. So you just turn those on. So now those are good. And then aside from like the material passes, we also want to do a couple utility passes. Ambient occlusion, which I showed you guys actually in Google a second ago. That's that shadow pass. Like that is one thing we can make. And there's also a depth pass. Okay, so back here, the utility passes are a little bit farther down. If you kind of keep going, eventually you're going to see a section where it says standard utility. There's a bunch of different options here. The only ones you need are depth and ambient occlusion, the top and the bottom one. Again, you can turn on other ones if you want. You can even turn on just to see what they look like if you're curious. Like they'll show up in the batch render. I'll show you how to see, like you can view it in Nuke. But you can just turn those 2 on. They will now automatically be created. And the ambient occlusion one is going to look kind of like that. Let me see if I have one in here somewhere. Yeah, okay, so this EXR file, this has all the passes in it. So there are all these different channels showing up. And the names are the same things that I picked earlier, like from that list. So for example, if I did ambient occlusion, there it is. It's done. Like there's my shadow path. I could now use that to like make shadows darker or do whatever I wanted with it. I've got, here's my direct diffuse, right? Indirect diffuse. There's the bounce light. You can't really see it because it's subtle, but there's bounce light there. But essentially it has all those different material passes there. And that's pretty much that. Okay. Okay, we got those guys all set up. So any questions about the material passes or the utility passes? It's just literally turning on the checkboxes. Really, really easy. Okay. And just kind of like a tip, just in case you guys want to use this later on for like another project, be careful about mixing Maya materials with Mental Ray. Because I know some of you guys are still going to use Lamberts and blends because they're easy. If you try using these with a Lambert, they won't even work. It's like not, Maya will have no clue how to take a Lambert and break that apart into this stuff. These are specific to Mila. So if you have any other materials in the scene, those guys just won't react with these at all. You'll probably see like a black pocket where the material is just rendering black because it doesn't even know what to do. So the MIA material would also have a problem. This only works with Mila. Now, the last thing we need as far as like passes go are going to be these Mila matte passes. This is probably going to be the hardest part about the pass section. This is a little tricky, but the matte one is right above it. See that little section where it says Mila matte pass? There's a little checkbox you got to turn on. So what this is going to do is allow you to control objects independently because we have the lighting separated, that separate lights. I have separated materials, which are these guys. But it would be nice to control an object by itself, like make the glass a different color if I wanted to, or change the saturation of the box, or something like that. Those are done through matte passes, and they kind of look like an alpha. I already have a bunch of my example renders, but you can see they're right here, like matte, and see how they're labeled for each object. So if I do like book 1, it just makes a little white alpha show up for the book. The pulley, scraper, and I have mine separated into like the metal and the handle as 2 different pieces, but This means that if I wanted to, I could pull one of those guys out, and then I could make like part of the render brighter or change color on different objects, but kind of cool. So the way you're going to set these up is, because I want to see it for every object in the scene, is go to that map pass thing, hit the checkbox called Use Map Passes, and then you're going to hit the Create Map Pass Material Set button right below it. Do you guys all see the relationship editor pop up when you do that? So this is used a lot. You guys have done it before with maybe like light linking. This is kind of the same thing. Like, this is how Maya sort of figures out what things are connected together. We're trying to do a map pass. So you probably see on the left side, there's something called Metal Ray Map Pass Material Set 1. If you click on it, what you want to do is, with this selected on the left, on the right side, just simply click through all the geo. And if you have them named, it's pretty easy because you can just see it. But you have to click on all the geometry, like the shelf, the wall, the books, the pulley. Try not to forget anything. And if you have groups, they work as well. So if some of your stuff is grouped together, that's also fine. You can click on the group, it'll work. Just click through all those guys. And when you're done, you can just simply close out of the relationship editor. It's finished. Now, the way to verify it worked, because you don't really know if it did anything, because you don't really get much of like a, like, there's no warning or, label that comes up saying you've done it, or if it's going to really look correct. Hit the little the Edit Map Pass button right below it. It takes you back. If you click on that same thing on the left, are you still seeing all your geo light up? Okay, good. If it is, it is probably working. Yeah.
In my relationship editor, I have this gigantic list of fully mesh shape prints, like 4,000.
Like on this side? On the right side, you're seeing all that?
Yeah.
Is there?
There's another scraper one that goes up to like.
It's called like shape, and it has a really like a bunch of numbers after it.
Yeah, it's like scraper colon. Well, the one I was saying. Like Philly colon poly. I think it's like the name for all like the vertices.
Yeah, it sounds like you're looking at birds, like components.
Why are
you seeing that?
Philly colon mesh shape underscore PNTS.
Oh.
37. Yeah, like all the regular stuff is up here, but then there's just this giant list of like.
Oh, down there. Yeah. Oh, because you're you're getting even textures. I think if you go under show, yeah, do one of those is probably turn off or on. It's different than mine. I'll bring mine up and see if I can figure out what it is. I mean, honestly, it doesn't matter. You're just not gonna click on them. Right. As long as you click on the geo at the top, you're fine.
Yeah.
So which one is this? Is this what happens when you go to the? Oh, you want to see? Okay, yes. So if you go to that little button, this is going to take you to the IPL, and you want to go down to the render stats. Not what were you clicking on before? Oh, yeah. So that's actually the layers attribute. It's not the IBL, which is different. If you click on this, this is the IBL attribute. So you're going to right click on primary, create layer override, and then do that to all those checkboxes. Yeah. And then when they're all orange, you just uncheck them. You just need to be on the layer. You don't have to actually select it. You're already on the render layer now. Yeah, you can actually see like you're on the key light. You can even change here. So it's like you get to go on the warm light. You click on the warm light, see it changes. You're on the warm light layer. You go back to the IPL. Yeah, that's automatically on it. Right. Yeah. Yeah, like, so some of you guys might be seeing more stuff. Mine might have it if I go, oh yeah, actually mine is doing the same thing as yours. Because if I go farther down on the list for the relationship editor, there's all sorts of like shading groups. I can see bump nodes, file, like everything in the hypershade is now showing up. So yeah, there's a bunch of other stuff here, but you just need to click on the geo. And if even in the outliner, you'll see there's that same thing is now showing up. It's called a set. If I hit that, usually I can hit the plus and it will kind of show me, but I think as long as you see it's highlighting in here, it's gonna be fine. It'll work. So that's gonna give us all those separate alphas, which is great. Everyone good up to this point? Okay, so really this is pretty easy, just kind of turning all this stuff on. Now we have a couple of things we need to do just to kind of get like the file format set up right. So every single render you guys have probably done, I know in this class it's been a lot of Maya, IFF. Were the other classes having you do IFF, or are you doing like JPEGs and Targas probably? Yeah. And those are fine. Targa's not really compressed very heavily. They usually look pretty good. JPEGs are compressed a lot, but they're very small size. IFFs are not compressed. I like using them, but you can only see them in certain software packages. Photoshop can read it if you have the plugin turned on. Nuke can read it. Maya can read it. But we're changing stuff up this time because we're going to be using something called EXR format. Have you guys ever made an EXR file? Okay. So the main benefit to this is, you know how when you do like a JPEG or a Targa, typically you only have 3 or 4 channels. It's either RGB or RGBA, depending on the file format, which is fine. But what we're talking about doing here, since we have all these render passes, these are other channels in the image. Like this, if this was a JPEG, I would have only been able to store this color information and that's it. There'd be nothing else in the file. And this means if I had all these render passes turned on, like we kind of do over here, if I change this format to IFF or JPEG or Targa, what's going to happen is all these passes are going to be split apart into physically different images. So now what do you think is going to happen to your images folder when you start doing batch renders for like full sequences? Yeah, every frame is going to be 5, 6, 7, whoops, I don't want that guy, 6, 7, and then I had like another 5 or 6 things selected in here. I mean, we're talking about like 12 different images probably per frame. And then you talked about 100 frame. Now 100 frames is turned into like 1,200 images. And now your images folder is ridiculous looking. And you're worrying about managing all these like, crazy big files. So what's different about this is with the EXR, this is not limited to 4 channels. This means that you can now put all these other passes in one file. It's amazing. I think the EXR file can hold 1,024 channels. You're never going to use 1,024 channels. If you guys actually end up using 1,000 channels in the EXR file, I would love to see what the hell you're doing. That better be an amazing comp, like using like passes I've never even heard of. But basically this has plenty of room. We can make a ton of different passes on it. So it's now one image as opposed to it being a dozen or so images. So to change the format, it's really easy. If you go back to the Common tab, just change your image format to Open EXR. It's just one of the options in the list. Super easy. Now at the top, it's a little hard to see here, but you'll probably notice it says IBL layer / some name.exr. You're probably seeing something kind of similar to that, even in your project. So this is the name that it's going to create for every image. What we want to do, though, is instead of this just using the same name, because all of these are going to be named kind of the same thing, but they're going to be in different folders, what we're going to do instead is if you just double-click in this file name prefix box where you typically type in the name of the image you want, just select all that stuff, right-click, and pick render layer. There's a bunch of different flags you can put in there. But if you pick render layer, see what it did to the file name at the top? See how it's naming your image according to the render layer name? So now you're going to have an image called keylightlayer.exr, warmlightlayer.exr, IBL layer. So if you have this in here, as long as you're naming your render layers, it automatically names all the images. Great. And you can get really creative with this. They do this a lot for like more complex shots, but sometimes you want to like label the camera you're using or a shot number. So there's a bunch of other options in here. So let's say you wanted to do something like in the future. You want to do something where you have the file named the camera _ something else after it. You could right click and pick like camera. I could do camera underscore render layer, and now this is going to be called render cam IBL layer, because the render cam is the name of the camera. I could even do something like, I could have it make a folder called render layer. If I do render layer / render layer, see how it's now making an IBL layer folder and then putting the IBL layer EXR file inside of that. So there's a lot of other ones in here we're not going to have time to talk about, like the scene name, render passes, but you can kind of use these to sort of customize how it names everything. But yep, it would do it for each render layer. Yep. Right. And the way to do that is you just have to have something like, it doesn't have to be even render layer. You could call it, monkey if you wanted to. Monkey / render layer. And now I have a folder being called monkey, and all the stuff's going in that one. Yeah, so you can, as long as you have a slash on there, / that kind of forces whatever's in front of it to make a folder. That's kind of cool. Okay.
Jared, real quick.
Yeah.
Before you move on,
Yep.
in your layers tab where you have your IBL layer, warm layer.
Yes.
The red, like recycle signs, what is that?
Yeah. Okay. Good question. Because you have like green showing up on some?
No, they're just gray.
They're gray. Might be gray. Are these turned off? Like, are those all black on the left? Okay. Is anyone else seeing gray? Oh, you know what I bet it is? Yeah. So, is there any chance you weren't rendering each layer when I was doing it? Like, were you just building the layers but not actually? Yeah. So I bet what it is. So this thing right here, if we turn it to that yellow color, what it does is, you know how I was kind of rendering these things in the render view just to preview it? This is a way to kind of tell the batch render to try using some of the temp information from the other renders we were doing to help it out. So like if you actually rendered the full image in the render view ahead of time and you had it set to yellow, it would use that image in the render view and just put that as the batch render. It's almost like saving cache data, kind of. And then if it's red, I think this forces it to auto render it from scratch anyway. But yeah, you're just not, it's probably gray just because you didn't render on the layer in the render view. But that is not going to make a difference. Okay, so we got that working, EXR file. We want to make sure it's set up for a single frame, just to make sure it's not doing a sequence. That would be a very bad idea. So right below here, frame / animation extension, it should be name.extension. It's probably doing that by default. So just make sure it's not that one. That is a sequence. If you see name.number.extension, you're about to start rendering 10 frames in a row. So name.extension. Okay, we're good there. Render cam, and we want to make sure the resolution is turned on properly. So render cam, yours might be set to perspective depending on the file you're in. Just be careful about that because Maya does default to perspective. That means when you render it with a batch render, it's going to be wherever the perspective camera was, which I don't want to see. So that should also be render cam, and this should be saying HD 720. And again, that's probably already set up like that by default. And the last one, I have it in here just to make sure no one hit it by mistake. The top one says apply output transform to renderer turned off. That's that thing at the way top up here. If you leave this on, I mean, does anyone see that on in their project? Okay, good. So no one has it on, which is good. If this is turned on, what it's going to do, you know how we have all this like color management stuff going on in here? This will cause the batch render to save it with the color management turned on, which might sound correct. Like it might sound like you want to see this stuff the same way outside of Maya, but you don't. Because if you're going a nuke, you actually want the images to look like this, because that's called linear space. That's what Nuke wants to work in. If you save an sRGB by turning that on, it might look good for posting on like your portfolio, just showing everybody else your final image. But if you plan on going into After Effects, Nuke, or anything else to like do post-processing on it, you don't want it putting that same gamma correction on the render. So that is basically like turning that button on and off for the batch render. But just make sure yours is turned off. Okay, so we've got all that. We're kind of in the home stretch here. I mean, really, we're just down to doing the frame buffers. And the frame buffers are probably going to be working even with default settings, but just kind of go over to the Scene tab, scroll way up to the top. Now, do you guys see where it says under Cameras, Primary Frame Buffer? I'm under the Scene tab, by the way, in the render settings. Data type, and it says RGBA half 4x16. Is everybody seeing the same thing? Does anyone see RGBA 4x8? Okay, good. So does anyone know what that means? Like, see how there's a bunch of other options here? Do you think you might know what any of these are trying to do to the file? I will show you. I'm not expecting you guys to know that, but like, usually you can kind of look at this and sort of figure out what some of this means. Like, notice how with RGBA half, it says 4x16-bit. But if I change it to like something up top, like RGB, see how it says 3x8? RGBA 4x8. So this number right here where it says 4 or 3, that's the amount of channels in the render. 4x16 means there's 4 channels, RGBA, each channel is a 16-bit channel. If you do something like 4x8, there's still 4 channels, but now they're 8-bit or 32-bit. And you can put, you could say I just want an alpha channel, but this one's going to be a really good default setting. And the reason we want to do that is because of how it stores the color information. So I actually have an example of kind of how this thing works. I'll load that up real quick. Okay. This is going to be fun for me. So do you guys know what binary space is? Okay, it's think of it kind of like the language of the dorks. It's just zeros and ones. You guys have all seen it. Like anytime you see that kind of typical code where it's like 0, 0, 1, 1, 0, 1, like all those, that stuff in like a chain. Like this is binary space. All this means is that it's using ones and zeros. Think of it like an on and off switch. 1 means something is on, 0 means off. Like everything you see, pixel color, software code, like all this stuff at the root of it uses that same format. Like everything uses zeros and ones. But when you save an image out of Maya, it's also saving that using binary space. So for example here, this is what a single channel looks like for an 8-bit image. So we're talking about like for one image, if I zoom into 1 pixel, we'll do this kind of bright one right here. So that pixel right there, you know how that's broken up into like 3 or 4 different channels? They all have different intensities, red, green, blue, alpha. That number for each channel, R, G, and B, when it's writing it, it actually looks like something like this, a chain of 8 different zeros or ones in a row. So the way this works is if you put a 1 anywhere, like let's say I had a 1 at the front and the back. Now notice how when you have an 8-bit image, each bit has a different number assigned to it. And see how the number keeps doubling as you go to the left? So if I have the 8th bit and the 1st bit turned on, it means that those 2 numbers right there are active, like they're on. So the result of this would now be 129 because it adds 128 and 1 together. So let me do a different one here. If I had the 2 in the middle turned on, so I have 0, 0, 0, 1, 1, 0, 0, 0. If those are turned on, those 2 numbers are now active. Those are the 2 values that it's going to use. So these guys would add together, which would mean my resulting number is 24. It's just addition. So it's just turning those different numbers on and off depending on where the 1 is sitting. Like that's pretty straightforward. So let me kind of test you guys out. What would the number be if I did that? So it's just 1, 0, 1, 0, 1, 0, 1, 0. What would that number look like? 170? So 128 plus 32, we're now up to 160, right? Plus 8, 168, plus 2, 170. So that's correct. That's the number 170. Now here's a tougher one. This is fun. how would you write the number 200? So this is backwards. But now that if you know what the number should be, how is that written in binary? So which numbers would have to be turned on in order for them to add to that guy? Start at the front. Would 128 be turned on? Yes. What about that guy? So what are we up to already just by turning those two guys on? Yep, 192. So what are we missing? Whoops, right there. That's it. That's 200. 11001000. Isn't this fun? Yeah, this is just basic math, which is not fun for most of you. Yeah. But for those of you that are like left-brained and yeah, this could be entertaining. So what does this all really mean? Well, so when you're using these to write colors, if it's just 8 zeros across like that, this is what black is encoded like. 0 means there's nothing turned on. That's a black pixel or black color, at least for like the red channel. So on the other extreme, if you turn all these on, what color do you think that would be? If everything's enabled. Yep, that's white. Now, what is the number if you add all those together for white? You've all seen this number before. This is a common number you've probably seen in Maya, Photoshop, After Effects, like even video games. So close. Yes. I'm gonna give the 256 credit though, because like they're both pretty much the same thing. If you add these together, it will equal 255. But if you count 0 as another number, there's 256 possible numbers it could create. But that number right there, 255, that's what white is encoded like, which is weird because the whole time we've been talking about this stuff, like for like every lecture, what if we kept saying the white color is equivalent to as a number? 1, right? Black is 0, white is 1. This is not what we've been talking about. This is completely different. What the hell is that about? Well, when it does this, just to make it easier for the artist, what happens is it normalizes those numbers to become 0 to 1, so it's easier for us to use it. Because you guys aren't going to want to go in there trying to figure out, okay, what number is 3/4, gray? Like, then you're trying to figure out what is that number in the middle here and trying to, 0 to like 200 or 180, whatever that is in that area. It's just not fun to work between 0 to 255. So all these software packages will take that range of values and they normalize it to 0 to 1. So 255 turns to 1. So it's just like, it's a user thing, like just making it easier for the artist. Now I'll show you where you guys have seen this. You guys have seen it in Maya in a couple spots. Let me go to material. Okay, so color, we've been using HSV, RGB 0 to 1, that's the same color, and RGB 0 to 255. So you could even pick colors in Maya according to the 8-bit value. Don't do that. It's stupid. But you could, I guess, see what it is if you're curious. Now the other spot, I think most of you guys have seen it, is Photoshop. And like I kept seeing this for years and I never really understood what the hell it meant. But you guys ever wondered when you start picking colors like red, what that stuff means? Like I'm picking this kind of burnt, kind of dark red, and it's telling me the red is 172. Like that's not 0 to 1. So these are now, like Photoshop by default gives you the 8-bit number over here for all the colors. So now you're seeing any particular color, what that does for their 8-bit value. And it changes. So black, you can see, is all 0. White is all 255. Now the other spot that I remember seeing it, which I thought was really was interesting, I remember seeing 255 from playing video games like with Nintendo and Super Nintendo. You guys still have, do you have an emulator where you play some of the old school games still? Have you guys played Final Fantasy VI? It's a great game if you haven't done it. It's like the one right before Sephiroth and all that stuff. But Final Fantasy VI, we're going to get dorky here for a second. Bear with me. When I was playing it, let me see if I can find someone who's got a screenshot of their attributes. Actually, it's in 7 too. So there's cloud. But let me bring up 6 real fast. Okay, here's 6. So this is just like you're seeing your stats boost up by like changing out weapons, like any other video game. But notice what's going on right there with the attack. We're equipping the Ragnarok sword. It's boosting the attack up to 255. And when I was playing this game, like of course, like most people, you want to like max the hell out of the stats somehow and get all the best armor and the items. When I was doing that, I noticed that a lot of my characters, everything kept capping out at 255. Like all the attributes would do that. Strength, defense, magic, evade, like all this stuff kept doing that. And then even when you go over to 7, like with Cloud, look what's happening here, 255. And some of you probably remember seeing that and not really thinking much of it, but it's the same thing. And so I just thought that Squaresoft was like obsessed with 255. Like this is some weird magical number that everyone like worships in some room. But what this is since a lot of these older games are really concerned about space and being efficient, especially on a cartridge, they know that as far as the code goes, there's going to be a lot of sections that just use an 8-bit chunk anyway. So they're using an 8-bit string of data as a way to keep track of different things. And they just figured like, well, if we're going to use 8 bits anyway, let's just use the full range of numbers just to keep track of different things in the game, like strength and magic and items. I think even when I was playing the game, I noticed like collecting items, there were exactly 255 slots in your inventory. If you collected one item, you could only have 255 of any given item. It was like all over the place. Now, we don't see that quite as much now, so it's not like you guys are going to be playing, Battlefield and every gun's using 255 bullets. Like, we're kind of not worried about that so much anymore because we have way more space, but that was something going on with the older games. So there you go. Now, when you start getting into 16-bit images, I'm not going to have you guys do this, don't worry. But see how when you go, like this is the first 8, and see how it keeps doubling with the 16-bit? This number it makes is huge. Even adding 1 extra bit will double the number. So when you double it 8 more times, this means one channel can do 65,000 different colors. And then you kind of think of what that means for all the channels combining together. That would be thousands, millions. That's 281 trillion colors for a 16-bit image. You can't see 281 trillion colors. Unless you have amazing eyesight, but I highly doubt you'd ever be able to see any of that difference. This one's a lot lower, but the main thing here is if you have a wider range of colors, this can eliminate something called banding. And you guys have all probably experienced this in Photoshop at some point. So I've got 2 different images I've rendered. One is 8-bit, one is 16-bit. I'm going to zoom in. Look at the back right here. I'm going to have to boost this up. See that? Have you all seen this thing before? Like if you make a gradient in Photoshop and you save it, and now your gradients turn to these weird arcs of like banded color. It usually happens from doing a really bad compression, like a JPEG or something like that. But this is an 8-bit image that's run out of numbers. It can't even make enough colors to make the gradient. And so now it's making these weird sliced chunks. But the 16-bit has way more numbers, and now it's like still maintaining the gradient, which is great. So we have a lot more color detail. Now the other one, this is still, 16-bit's great, but the one you guys are doing is different. The one you're doing in the lab is called 16-bit half. This is probably like turning you guys off from ever doing this ever again. Like I'm never doing shading and lighting. This looks terrible. But the main thing with this one is instead of this just generating some random super big number, kind of like the other guys were doing, this one has all the 16 bits broken up into sections, and it uses those different numbers as part of an equation. And you guys have actually seen this before because you've all done this probably in middle school or some of your earlier math classes. Do you remember what it's called when you have some number times 10 to an exponent, and then depending on what that exponent was, you'd like move the decimal to the left or to the right? You guys don't remember that stuff you learned 10 years ago? No? Okay. That is scientific notation. Yeah, I know I blocked that out of my mind for a reason. But that whole thing called scientific notation, where you're just moving decimals around, like 138 times 10 to the negative 2, basically like these numbers right here just make some large integer value. This is the number used for the decimal, or for the exponent, sorry. That just determines if it's a positive or a negative sign for the exponent. But when you essentially, when you put all this stuff together, this means this type of file format can make numbers with a decimal place, like 1.38, 0.0846. These only made whole numbers. They don't know how to do decimal places. So this little guy right here, because it can do a decimal place, the thing that's different is it allows it to save values above 1. These are called super whites. So see I have my little Obi-Wan sticker here. So this is 8-bit. That's 16-bit. Now you can tell something feels different. Let me drop the exposure down. I'm going to do something called a wipe in Nuke so I can kind of see both images at once. I'm going to drop the exposure. Watch what happens to the 8 and the 16-bit image. They look way different now, right? They were kind of close when I first started, kind of blown out. But you can tell when I lower it, this one looks a hell of a lot better. And that looks just like a weird flat gray. So the reason it's doing that is because since these other guys back here, these can't save numbers above 1. Like this is going to be normalized to 0 to 1. It doesn't know how to do anything above that. So this means when you look at a render like this, when things blow out to a white, everything that gets white is the exact same number. So when you darken that, all those white pixels turn to a very weird flat gray. But because this one saves values above 1, there's still texture information there. You can now take an image that's blown out, darken it, and there's still something there. Like you didn't lose any information. Even if you don't really understand any of that, it's cool. Just do it. Like you want to have this for pretty much any batch render because having more math and data is always a good thing. You want to be able to use this stuff in post and not run into like some weird problem where you're trying to change a highlight and then it's doing this stuff right here. This is all over movies, by the way. Because when you start recognizing this, it's going to ruin movies forever. Michael Bay has a really big problem of butchering his movies by color correcting stuff in post. Because you know how Bay and even Abrams have these like color palettes they kind of go to a lot. Abrams for a while was doing that kind of a teal and orange thing. Lots of lens flares and glints on everything. But Michael Bay would color correct his stuff in something like Premiere at the end. Well, when he has it as a movie format, movies are only 8-bit at that point. So they've lost all these values above 1. So when he goes in there and starts tweaking stuff and adding these stylized color effects to all of his shots, you'll notice that a lot of things that look like they should have been white turn to these very weird muted grays. Like highlights will look kind of weird and flat. Clouds that are supposed to be blown out with the sunlight next to it, they're turning to very weird flat blues and grays. It's on everything.
Watch Cloverfield.
Yeah, watch Cloverfield again, and then like have a drink ready, because you're going to be seeing all sorts of very weird problems like that, where it's got tons of clipped and clamped values. Okay. So a lot of binary space stuff. So what does this all mean? After I've just bombarded you with numbers and math, it means that your default settings are totally fine. Just like, yeah. I just want you to be aware of it because you'll notice in some versions of Maya, it changes these. Like you might see it set to an 8-bit image. Like Maya 2015 and earlier, all were set to 8-bit by default. That wasn't good. So I used to have all my students change it to this, but now it's the new default setting, which is fantastic. So this is good. If I go back here, the other thing I want to check is that not only the primary data type is set properly, but the render passes also need to use the same thing. So render passes are a different part of the file. They need the same information. So if I go back here to Maya, just scroll down. When you go past the passes, you'll see there's the passes data type. 3x16 half. Perfect. It's already set up for default, and we're good.
So it doesn't need the fourth gen?
Nope, this one doesn't need it because we kind of think about how these passes work, like a direct diffuse, for example, like your texture. That's just made up of RGB. You don't need the alpha channel, so that's kind of irrelevant. So all these different material passes, they only need 3 channels RGB. And even though we have an alpha technically on the original image, we're never going to use it because the alpha is just solid white because the whole scene just has stuff there. So even the alpha is not really needed, but we're just leaving it there anyway. So that is essentially it. So once you guys kind of get through all that, you're just batch rendering. Like bump your settings up just like you did before. And when you do the batch render, so over here inside the project, be careful because this thing is going to batch render all 3 layers. And you don't want to do that because you're going to be waiting forever. And you kind of want to verify that one of them looks good before you probably jump to the next one. So what I'd recommend you do is over on the render layers, turn off the layer by hitting those buttons on the left. So see how my only one turned on is the key light? It's that little button right there. Just make sure one layer has that left button pushed in, so it's enabled. Then kick off the batch render. I'm not going to do it. It's going to take too long, but kick off your batch render. It'll start. Eventually, it'll finish, 30 minutes down the road. And when it's done, if you want, you can bring in a nuke. You guys might want to download nuke just to see it because EXR files are really hard to preview in any other application. Like Photoshop won't open them. So when it's done, you can bring in a nuke and look at it. I'll show you how to do that. But then if you think you're good, just go to the next layer, turn it on, batch render again. Wait a bit, check it, go to this one, batch render again. I mean, if you can turn them all on if you want to do that overnight and just let it wait, but my computer goes to sleep a lot and stops the batch render, so I kind of like doing it like 1 layer at a time. Yeah.
Okay, so most of the information that you've given us is for the IBL layer. Are we supposed to do that for every layer?
Oh, it's actually like all these things like the passes, if you actually look at each layer, it applies to all of them automatically. Yep, so the only thing we had to change on each layer was just like the overrides on the IBL to turn it off and swapping the lights out. But all this other stuff like data type, frame buffers, passes, map passes, when you make them, they're automatically on every layer. So you do it once and you're good. Yeah.
Are there any settings in the batch render that we should be aware of, like whether or not something should be clicked off?
This stuff? No, I think you should be fine. You're probably using the same settings I'm using right here. Like everything's just turned on auto. And by the way, this is just in the batch render options right there. I think you're fine with that. If you guys notice it's crashing, you could maybe change the auto memory limit. I mean, have you guys, I know Maya crashes. That's different. Have you guys ever run into something called a memory, like fatal error at the bottom, where like a red error pops up? It usually says like memory error, memory fatal error, memory ... Yeah, I think it's because all your laptops probably have 16 gigs of RAM in it. Maybe some of you have 8. I don't know if you guys know. Yeah, you're probably all 16. You just have enough memory in your laptop where you'll probably never run into a memory issue. But if you did, you could like force the batch render to use less memory by typing something in there. But you're not gonna have to worry about that. So I'd say just leave it at default. You're fine. Yeah, question.
In regards to Nuke, say about downloading it, were we supposed to get like a student email?
Yeah, did you guys all get an email already? Some of you did, some of you haven't. Are you taking compositing next month? Are you in compositing next month? Do you know? They usually send it out like a month before you hit the class for compositing. You may want to check your emails again. I don't know, like who sent it to you? Is that the Foundry or is that Full Sail sending you the... Full Sail does it? Yeah, I don't really know what you'd have to search for. Like find someone else who maybe has got the email so you can see if you can find like that in your inbox. You should be able to get it. I mean, even if you don't have like the full official version, that's totally fine. If you go to the Foundry, that's the company that makes Nuke. They have a lot of stuff, but if you go to the Foundry's website, you can also just manually download the product on like a trial. And that'd be fine for today, like the weekend, just like using the trial version. And then when you get to compositing, you can talk to Jonathan and Pedro or Juan. Like they'll hook you up with the license and get you all set up. But you can still use like the 30-day trial. And Nuke's right there. A lot of other ones you may want to look into at some point. Like Mari is like a 3D texturing program. It's pretty sweet. Yeah, Katana is like lighting. There's some that have like a lot of roto and tracking kind of built into it. All their stuff is pretty much centered around like post-processing, editing, roto, alphas, keys, things like that. But over here, once you click on Nuke on the product, like you can just get the free 15-day trial, and that would be fine just to like test stuff out for this class. So I do have like just a little bit of time with you, and since I'm recording this, it might be cool for me just to kind of show you like a super quick comp and just like what you can do with this stuff. So here's Nuke. The main thing with Nuke is it's a node-based program. It's very similar to the Hypershade, and if you guys like feel comfortable in the Hypershade at this point, Nuke is going to feel like a walk in the park. Nuke it's just way more efficient. It's laid out really well. It's not as complicated. But these are all nodes. There's a curve editor, dope sheet for timelines, all the properties. This is like the attribute editor on the right. So let's say I had EXR files. So when you bring in your image, you can just simply drag any of your EXR files right in the node graph. Just by dragging it in, it'll appear. It's there. Now, when you want to view something in Nuke, you just connect it to this viewer node. It's always in your node graph by default. You can also hit 1 on any node that does the same thing, the 1 key. And if I do 2 on another one, I can do 1 and 2 and flip back and forth between 2 different renders. Yeah.
So we are using Nuke for this assignment?
No, I'm just showing you how to preview stuff, and like some of you may want to use it and still kind of play around with different things. I think I would at least download it just so you can make sure things look good. So for example, let's say I wanted to verify this looked right. Like here's how I grade your project. I'd bring your image in. I'd first make sure visually it looks correct. Like, yep, that looks like the key light. All the materials are there, relatively clean. I don't see any grain. So when I kind of go through my checklist over here, I need to make sure that the passes are there. All the, the map passes, the data type. I mean, basically all I'm doing is I go to your image, and at the top, when you view it, where it says RGBA, I'm just simply clicking on it, and I'm making sure these exist. If I only see RGBA and nothing below that is here, that means you didn't do any of the render passes. Like, they're just not even there. But we have them, so I can click on one and just make sure it looks good. Like, I don't click on every one of them. It just takes too damn long. But I'll go direct diffuse. Yeah, that seems okay. I might click on like a random glossy pass, like for transmissions. That's the transparency. There's my specularity from the key light. Yeah, question?
This actually goes back to the batch renders. If you do it with separate layers because you wanted to do it one at a time, but it takes long, is it going to be in the same file, or is it going to?
It'll have different files because. Remember in the comment tab, we set up the name to be called the render layer. So it's going to be a different image because each layer is named differently. So yeah, they're not going to overwrite each other or anything like that.
And when we submit it, are we like just put them all in one folder?
Yep, you just put them all in one folder, 3 different renders. But so these are all here, and I might click on some map passes like the book, the scraper. I usually kind of make sure you have all the objects, like you didn't miss, the washers or the pulley, but they should all be there. And then you can see my ambient occlusion thing is turned on. Now the depth one looks kind of weird. Here's depth. Does that look cool? Sweet, man, red color. But see how Nuke shows you the value for the pixels down here? There's something there, because you can see the numbers changing. It's not just red. So the reason it looks like that is because the depth pass is really, really bright. See how it looks like a fog, like things are fading off in the distance? What it does is it just converts distance to value. So like, if I was the render camera, let's say you're in Maya, you're 20 units from me, it would write your number as 20 in the render. So it just converts distance to value. So like right here in the render view where it says like 103, that's probably the wall. That's 103 units from the camera. That's all it means. All right. So here's me like just doing a really quick comp. eventually when you kind of use this stuff, you're going to want to try to break the passes apart so you can control them. This is using a shuffle. And again, don't worry about following along, if you don't have Nuke. It's all going to be in the video. But if you want to do this, you can make a shuffle underneath it. I'm just hitting tab, just like the hypershade, typing in something. You can also find the nodes by right-clicking. They're also over here, same things. Here's the shuffle. But you make a shuffle. This thing is going to pull channels out of the image. It looks kind of really confusing. Like, what the hell is this? But basically what it's doing is it's extracting channels and trying to figure out what channels I need to pull out. So because I'm trying to pull these passes out, over here I can say, let me pull the direct diffuse out. So the direct diffuse is only 3 channels, RGB. There's no alpha. See how the output is looking for an alpha, but it doesn't exist, so it's using the blue channel. So if I look at the shuffle, it's now my direct pass. And if I do RGB, I can see each color channel is black and white separately. And the alpha at the moment looks like the blue channel. They're the same. But I could tell the output to only do RGB, so there is no alpha. RGB. And essentially, like, this would be one of the passes. And you could label it, call it whatever you want. You can kind of see it if you wanted to. This is called Alt-P. They call them postage stamps in Nuke. I don't know why. It's a swatch. But Nuke calls them postage stamps, so we can ship it somewhere. I don't know. But when you kind of do this, like, I could basically break apart all the passes. So I probably have a few of these guys, connect them all to the same original image, just dragging all these shuffles to it, just copying them. So they're all the same thing, but what I would do is on each one, I'd go to the next one, change it. This would be using the next pass. You see how it's changing? Diffuse, that's my spec. This one would be indirect diffuse. Indirect spec. And then that guy, my transmissions. So actually, I don't even need this one. This is an extra. These other guys I don't need to pull out. But these are all the different parts of the material. Like, all these together equal that one. What if I put them all back together again? And just kind of like, After Effects or Photoshop, there has to be different ways to mathematically combine images together. So instead of it being a layered thing, this is using these different merge nodes, which is sort of like a layering system, where I can pick 2 different images to combine together. So if I added these 2 together and say, these are all the Photoshop blend modes, like over, overlay, in, out, max. If I do plus, which is addition, that plus that equals that. See how it's like adding them together? And then I can basically just continue that right down the chain, put them all to a plus. And this can all be scripted, so you're not doing this over and over again. Connect them all up to the next node. Snap it into place. Let me just flip these real quick. And now that should look like the original. Yep, so here's the original. Look at my end result. See how nothing's changing? It's the same thing. Because these, again, will look like the original if you add them together. So this, plus that, plus that, plus that, plus that. Just adds them all up. But the cool thing about doing that is if you separate them apart, this means, like, right here, for example, that's my transmission pass. That's the glass. So what would happen, do you think, if I put some type of color correction right there under this guy? It's only affecting the glass. So this means if I put like a grade, the grade is kind of like a levels and HSV all in one. It's like your color correction tool. If I just drop a grade node there and say under the transmission pass for the refractions, I'm going to make this turn green. Done. Now we have green glass. I could go to so we have highlights over here. Maybe I want to make the highlights brighter. Same thing, drop a grade. There's my spec highlights from the area light. Take that multiply, bump it up. Now it's brighter. And you can all see that on the final. Now the things look almost metallic now because I'm like making them super reflective, but I mean it's working. Okay. But yeah, so that's kind of why you're going to end up using those passes. You'll do that a lot in compositing. You have a question?
On that second grid that you did, you could use the material mask, or the material pass.
Right, yeah. So
There is a mask.
yes. So what she's asking is, let's say I want to make the spec highlights brighter, but you're talking about maybe like visually, the art director wants to make just the handles reflections brighter. So if I do it right now, this is affecting the whole image, right? Everything becomes brighter. But remember how back in the original image, we've got all these matte passes we made, like the pulley, the shelf. That's like the trick, because like this grade node has a mask connection on it right next to it. So what I could do is if I wanted to make sure this guy right here is only affecting, we'll do the scraper handle, I guess. I'm going to bump up the reflectivity a lot just so I can see it. Maybe like we'll double it like that. I'm going to take the mask from that and drag it back to the original image because that's where all these guys are. And what I'm going to do is on that grade node, see where it says mask, I can pick any of those guys from that original EXR file. So if I did something like scraper handle, it's only doing the handle. And I can pick any one of these guys. I could like say, you know what, it should have been the shelf. And now, it can't really see it because the shelf's not doing anything, but you guys kind of get the idea. Now I'm making one of the washes brighter. So that's pretty nice. Okay. I showed you guys like the coloring thing. Like you could change light intensity by raising everything up and down. So I could go in there and like drop in a grade or like an exposure node and end up like making things brighter, you know, to make the sunlight more intense. Or if you're doing like some weird sci-fi shot or you want to like Michael Bay the hell out of something, you can get into some weird colors and start tinting things. Like we're going post-apocalyptic, so I want the sky to look red and crazy, like Fallout. And now I have like weird red color coming through the window. But the other thing here is I kind of want to show you guys this depth pass and how you use it, because this thing's really cool. You can do depth of field in Nuke really, really quick. So depth of field, if I drop a Z to focus, you'll probably use this eventually. See how everything just went crazy blurry? Something called the focal point. It's trying to figure out, like with a camera, what you're trying to focus on, so it knows what's going to be sharp, what's going to be blurry. Now, if I move it around, you'll see nothing. Well, it's changing, but see how it doesn't really look like anything's blurry? Like it's just very clean everywhere. So it's looking for a depth pass. Actually, oh, is it already working? How funny. I'm surprised it's even doing that. Is my depth pass already here? Oh, that's kind of cool. I'm actually kind of surprised it did this. Normally I have to like copy the depth pass in, but I'm kind of looking at this final node and I can see the depth pass has actually made its way down through the chain. Like I thought what used to happen in Nuke is if you extracted these guys, the depth pass would be stuck on the original image and this wouldn't know what to do. But it looks like the depth pass has made it all the way to the bottom of the script. So actually by default, this is kind of working. So if I put this on the vial, should click. Yep. Depth. And I'm going to crank this thing up a little bit. We'll do like a 20 pixel blur. And now it's focused on that guy, and you can see it's like putting everything else in front of it out of focus. This is way faster than doing it in Maya. Like Maya has depth of field. It's called a bokeh lens shader. It is insanely slow. Like 5-minute renders turn into 2 hours. Like, don't do it. It's a mental ray thing. Actually, pretend like I never said that, so you don't even know to look for it. But if you are going to do depth of field, you can do it in Nuke, and you can like move this guy around, figure out what you want to focus on. This is how you do rack focuses, like changing. Like if you have a moving camera, you might want the camera to like change what it's focusing on as it's going across like a model or like through an environment. So you can actually keyframe this guy and sort of pick what you want to look at as you're going through a shot. It's awesome. I mean, you do want to be a little bit careful because if you end up like, because a lot of people have used this and they like the depth of field a lot. So what they do is they apply crazy depth of field to everything, thinking like it's going to make your reel so much better. The problem with that is if you do it, you're going to end up with this. And some of you guys have probably seen this thing before. Like, okay, this right here, that is a real photograph. Looks like miniatures, right? Like little toy cars, little mini people. And they're all like that. Like, that's a real city. And the reason it looks fake is because the camera is putting things out of focus like it's a really tiny object. So you guys have seen this with like macro photography, like the little, this is when people take pictures of like bugs and ants, like all this stuff. Like see how out of focus things go when you're doing really, really small scale? That is being applied to this stuff, and it's not natural. Like that does not happen with a real camera. So you need a special lens in order for it to do this. This is called, again, tilt shift photography. But we've had a lot of people end up cranking their depth of field so much in Nuke that they have these scenes that are like huge Roman Colosseums that look great. Then they put the camera way above natural eye level, like it's floating 60 yards in the air. Then they crank the depth of field, and now their Roman Colosseum looks like a miniature toy on a tabletop. We kind of lost the effect. But yeah, you don't want to crank it too far. Kind of a cool effect though. So anyway, those are all things you're going to kind of do more when you get to the compositing class. I just wanted you to at least see kind of why we're doing this stuff. There's a lot of control, like depth of field, vignettes. I didn't even get into glows, but you know, some of these highlights are really bright. It'd be nice to make that bloom and kind of glow a little bit. I could do that in Nuke. But just as kind of like for what we've sort of talked about, do you guys like have any questions about what Nuke is doing? How do you like preview your images just to verify they look right? I mean, it's really just dragging it in there and making sure all these passes exist. You don't have to do any of the comp work. If you want to, that's all up to you. Everyone good? Okay. So a lot of batch rendering today. I haven't graded the projects yet, but if you guys still need to submit it, do that today. I probably will try grading some of it tomorrow, but I might not even get to it till next week. But as long as you guys submit it today or at some point over the weekend, you're going to be fine. I'm not taking off late points. I think that's pretty much it. How'd you guys like everything for the month? Like Mila, it seemed like, hopefully this is like brought some clarity to shading and lighting. It's not as intimidating. I swear this stuff is fun. Like once you know what the hell's going on, this is a pretty cool part of the pipeline.
I like Mila better than MIA.
Oh, the Mila is amazing, right? Like the MIA is like a joke when you go, like once you understand the Mila and just stack stuff up, it's like the most logical material I've ever seen in my life. Yeah. Cool, I'm glad you guys liked it. So that's pretty much it. This thing's actually still recording. Thank you, QuickTime, for not crashing. So I'm going to save it. I'll post it online. I'm going to send you guys a group email, like according to your Full Sail email address with the link. This still might take a bit to upload. So if you don't see an email from me by the time you guys get to lab, don't panic. It's still probably converting. It should be up there at some point tonight. You'll get the email. But you're not submitting this until Sunday night anyway. You have plenty of time to wrap it up. And I think most of you guys probably know what to do anyway. Cool?